Heat treatment process and value engineering. Heat treatment is a process that involves heating and cooling metals and alloys to change their properties. It's a crucial part of manufacturing and is used to make materials stronger, more durable, and more resistant to corrosion. Heat the material to a specific temperature. Hold the material at that temperature for a set amount of time. Cool the material quickly or slowly, depending on the desired properties. Types of heat treatment. Annealing softens steel, removes gases, and improves magnetic and electrical properties. Normalizing relieves stresses and improves ductility and toughness. Hardening increases the strength and brittleness of a metal. Some benefits of heat treatment process are: improves strength, hardness, and toughness. Increases temperature resistance and ductility. There are two mechanisms that may change an alloy's properties during heat treatment. The formation of martensite causes the crystals to deform intrinsically, and the diffusion mechanism causes changes in the homogeneity of the alloy. Unlike iron-based alloys, most heat-treatable alloys do not experience a ferrite transformation. In these alloys, the nucleation at the grain boundaries often reinforces the structure of the crystal matrix. These metals harden by precipitation. Typically a slow process, depending on temperature, this is often referred to as age hardening. The specific composition of an alloy system will usually have a great effect on the results of heat treating. If the percentage of each constituent is just right, the alloy will form a single, continuous microstructure upon cooling. Such a mixture is said to be eutectoid. However, if the percentage of the solutes varies from the eutectoid mixture, two or more different microstructures will usually form simultaneously. Proper heat treating requires precise control over temperature, time held at a certain temperature and cooling rate with the exception of stress relieving, tempering, and aging. Most heat treatments begin by heating an alloy beyond a certain transformation, or arrest, a temperature. Value engineering. Value engineering, VE, is a systematic approach to identify and eliminate unnecessary costs in a product, service, or project by analyzing its functions and finding cost-effective alternatives without compromising quality or performance. VE is a structured process that focuses on optimizing the value of a product or service by examining its functions and finding ways to achieve those functions at the lowest possible cost. How value engineering works in the industry. Identify functions. The first step is to identify the essential functions of a product, service, or project. Analyze costs. Then, the costs associated with each function are analyzed. Generate alternatives. Next, creative solutions and alternative methods are explored to achieve the same functions at a lower cost. Evaluate alternatives. The potential alternatives are evaluated based on their cost, feasibility, and impact on functionality. The reasoning behind value engineering is as follows. If marketers expect a product to become practically or stylistically obsolete within a specific length of time, they can design it to only last for that specific lifetime. The products could be built with higher-grade components, but with value engineering they are not, because this would impose an unnecessary cost on the manufacturer, and to a limited extent also an increased cost on the purchaser. Value engineering will reduce these costs. A company will typically use the least expensive components that satisfy the product's lifetime projections at a risk of product and company reputation. Due to the very short lifespans, however, which is often a result of this value engineering technique, planned obsolescence has become associated with product deterioration and inferior quality.